Okay, so I just wanted to make a quick disclaimer over this video because you're going to see me handling snakes, which I do not recommend unless you know what you're doing when it comes to snakes. I have done plenty of experience with these snakes. I know what's venomous and what's not. However, you might not, right? So I think that it's best that you stay away from snakes unless you really know what you're doing, and maybe go after a different animal that is more suited for your level. You can do bugs, salamanders are great. Really any animal you can still do this experiment with. You just need to think of your own key attributes and you can measure whatever. Just do it, because I really don't want to be responsible for anybody that goes out and sees a snake thinking it's not harmful, just thinking that it's the same one that's in my video, and then ends up getting bitten by a venomous snake and would have to go to a hospital where they could be in a very bad situation. So I would definitely advise against snakes unless you know for certain what you are doing, and especially don't go after any snakes unless you do what you're doing without adult supervision. Now that that's said, let's get started with this. Hi, today we're doing an experiment about the genetic variation in different species. So what you're going to need for this experiment is going to be a ruler, some sort of container. This is a plastic Tupperware container. You can also use a bucket, whatever works, because we're going to be dealing with a live specimen. A scale is going to help you out. Basically what we're doing is we're trying to measure the different attributes of the different animals. So first step is you're going to need to go out and get the different species. What I'm using today is going to be frogs and snakes. This snake that I am using is a northern water snake. I can get you an example of that right now. So this right here is a baby northern water snake. He's going to be one of our 5 specimens that we're using. Not all of them are babies, but this guy is. So that's going to be the gist. We're going to measure them, and then I'm going to go over what that means in terms of what they do in the wild and how that's going to help them survive. Yeah, let's get to it. Welcome back. So once you've gathered all of your animals, you're going to want 5 of the same species for each member of the group. I'm going to be showing you 2 just so you know how to do it. So first you want to pick what you want to measure, right? So for the snakes, what I'm going to be doing is I'm going to be measuring their length. I'm going to be weighing them, and then I'm going to measure the width on their head, and I'll tell you why that's going to matter in a second. So once you've gathered them, just come back and then we'll show you how you're going to do the experiment. Okay, so with the snakes, first I'm just looking at them, seeing if there's any differencing. With these 2, you can see that one has a bit broader bands, and it has a bit warmer colors, while the other one is a more blue color. These snakes, the thing of one of them has a much darker belly, while the other one is pretty light up top, at least. So now that we can see that this one's a bit bigger than that one, we can just really see the different colors in them, but they look pretty similar. Now that we can see the differences in their just looks, we're going to be looking at their length, their weight, and their width. So we're going to first start with our first specimen. We're going to be measuring his length. Let me just do that real quick. We'll be measuring in centimeters. This guy is 29.5 centimeters long. Next, we're going to be measuring the width of his head. This guy's head is 1/2 a centimeter wide. And just be making sure to mark this in your journal. I already have marked this, but because I did this previously. Next, we're going to get our scale. It's zeroed out with the little container on top, and then I'm just going to weigh them. We're going to be using grams. This guy weighs exactly 10 grams. So once we write that down, we're going to do the next specimen. Okay, now we have specimen number 2. You can see this guy looks like he's going to be a bit longer. He looks like he'll probably weigh a bit more. We're just going to test that out now. So first, I'm measuring length. Yep, this guy is 32 centimeters long. Then we're going to be measuring the width of his head. So, the width of this guy's head is 3/4 centimeter wide. And lastly, we're going to be weighing him. This guy actually weighs 15 grams. So, now that we have 2, let me just talk about a few things and why they matter. So, we know this guy used to have the same amount of, you can just see his pattern relatively similar to how you can see the other guys. What that means is that he's still a juvenile snake, obviously, so we're going to say that these are probably around the same age. So that's going to lead me to believe that this guy is going to be a female and the other guy is going to be male, because in this species of snake, the male are going to be smaller and the female are going to be bigger. So since this guy's bigger and they look to be about the same age based judging on their marks, I'm going to guess this guy's a female. So what the means of the width of the head actually is they're going to be much more scarier for their predators, right? So basically when these snakes are mad, they flatten out and the width of their head grows and it looks triangular. So the wider it is, the more likely a predator is going to see them and think this is a venomous snake, because that's one of the key attributes of a venomous snake, is that it actually has a triangle. Now, before people started hunting these snakes, that helped them out, but now it's starting to decrease their chance of survival as people see them and they commonly mistake it with the water moccasin. Now, this guy, he's bitten me, but he doesn't have any venom, so I'm going to be fine. However, a lot of people don't know that, and they see these snakes, think it's a dangerous, venomous water moccasin, and they end up killing him. So, sadly, this guy probably has a bit less chance of survival than that guy. Okay, so now with specimen number 3, we're getting into our smallest water snakes. So, this guy, just by looking at him, we can see that his pattern is super visible, which probably tells us he hatched about within these past few weeks, probably somewhere between 2 weeks ago, 2 and 3, maybe longer. We can see that his head is still pretty small, rather dark coloration on the bottom towards the tail and lighter up top. Definitely smaller than the Fast 2 specimen. So we're just gonna measure this guy. If he'll settle down for a second. Sorry, buddy. Yep, so this guy is 21 centimeters long, and he's flattening out a little bit because he did not like the measuring. You can see him head almost to that triangular shape, but he's not very big yet, so he's not able to achieve such a scary, venomous snake look towards predators. Next, we're going to be measuring the width of his head. So this guy is just under half a centimeter long. We'll call it a 1/4 centimeter wide, I mean. Yeah, so now that we've done the measurements lengthwise and width, we're going to weigh him. Let me just make sure our scale is zeroed out here. which it is, measuring in grams. Now, we're going to put him in there. And he looks to only weigh about 5 grams. So, definitely smaller than the past snakes. This one is definitely going to be a pretty snake when he gets older, just judging how cool the patterns look. So, that's it for this guy. Okay, so this guy is our 4th specimen. He has very distinct patterns, maybe not as bold and clear as the last guys. He looks to be about the same size, maybe a bit smaller, I think, yeah. At this age, we cannot tell if they are male or female. That goes for the last specimen too. So, let's just get to measuring him. So, he is coming in at... So what he's doing right now actually is he's rolling. With these snakes, when they feel threatened or if they're trying to escape, they roll. So lizards, they can just break off their tail, but if you're holding one snake just by the edge of its tail, then what it will do is it will roll and then it will snap the tail off. I try not to let them do that because I don't want to cause them any pain, but you know, there has happened before. So this guy has measured in at 21 centimeters long, so a bit better than the last one, I think, but definitely still a baby snake. Now we're going to be measuring its head, its width. So that is going to just be about the same size, a bit under half a centimeter, probably between 1/4 and 1/2. So last, we're going to be weighing him. Scale zeroed out at grams, and this one weighs only 3 grams. So this guy seems to be a bit longer than the last one, but also more slender. So yeah. Also, on this one, you can notice that very, very light coloration on the bottom relative to the past few ones. So, yeah. Baby northern water snake. Let's get to the next specimen. Okay. So, this is our 5th and final specimen. He is not a baby, as you can see. He still has pretty nice, bold, distinct colorations in his pattern, so that tells us that he's not full grown. He was probably a hatchling from last year, maybe 2 years ago. We can see towards its tail that it has a bit of wounds, so that tells us that he has escaped a predator. That is either his, so yeah, he has a bit of cuts that could be from a predator or just environmental thing, like getting stuck in some sticks and then it getting scraped up. So this guy is not quite full grown. They will get ways a little bit longer than this, but we can tell that he is probably a female, or she is probably a female, because it's pretty big for having coloration this distinct and bold. So now I'm just going to get to measuring. I'm going to need to mark where in the snake that ruler ends, because he's definitely more than 30 centimeters long or a foot. Okay, sorry, buddy. Okay, now I'm just going to take this much. So remember, that's 30.5 centimeters for the ruler. So add that last bit on. So he is going to be a total of 46.5 centimeters long. Definitely not full grown. They'll get closer to they'll sometimes reach about a meter long. So they do get quite a bit bigger than this, but this is the biggest one that I was able to find. So yeah, in the next clip I'll be telling you what you should be writing down in your journals, and just what you are going to be making conclusions about the snakes based off of what you wrote down in your attributes. Okay, so once you've used whatever animals you used and you've measured their attributes, what you're going to do is you are going to write down what you think what animal is going to be most likely to survive given that its attributes. So what I think is that the specimen number 2, that one had a much wider head for its for the size of it. So it's going to have a more triangular head, which is going to make it look more like a water moccasin. So I would wager that is going to have a less chance of surviving, because there is a lot of people that go out with their family and they see these snakes and they think that it's a water moccasin, so they try to protect. Maybe if they have kids, they don't want to get bitten by a venomous snake, so what they end up doing is they end up killing the snake. So sadly, I don't think he's going to survive as well as specimen number 1 is, because he has a rather small head. Now that does come into play with predators quite a bit though, because there's also the reverse of that, is that the big head would save them. But nowadays, especially in this place where I caught them, the creek that I went to, they're very, very good environment. So their main predators are going to be humans, because of the amount of people that end up walking through there and the amount of people who kill the snakes. It is a problem. I go down the creek and I see many people. I've seen some people killing the snakes, and I've seen the dead snakes on the floor, the ground. So yeah, I feel bad for that guy, but you know, if I were to guess which one would have the most chance of survival, I would guess the biggest one, because that guy has already made it 2 years and it has already survived for the hardest part of their life. Quite a large percent of these snakes die during these years when they are very little, because it is just the hardest time for them to survive. So what you're going to do is you're going to write your conclusion about what snake or whatever animal you did is going to be the most likely to survive, and you are going to give your reasons why, and yeah, just state your conclusions. Next up, I'm going to be showing you the experiments that I did with the frogs. I'm just going to tell you the different attributes. I'm not going to be using the same ones as the snakes, because I'm trying to figure out the attributes that are going to make the key differences, whether or not these animals are going to survive. So yeah, catch you in there in a second. Okay, now that we finished measuring the snakes, we will be doing the frogs. We have 5 different frogs, all various different sizes. So first, we're just going to be looking at them, seeing what the key differences between all of them just by sight. Then we're going to get to measuring them. So what we're going to measure is going to be the length of the nose to their tailbone, and then we're going to be measuring the length of an individual leg, and then just their width. So and then I'm going to explain to you why a certain frog may be more suited for their environment because of their attributes that we're going to be measuring. So without further ado, let's get into it. Okay, say hello to frog number 1. As you can see, this one has the yellow throat. The bigger ones will, but it's normally I don't find them this size to have that throat. So it's not as big as some of them. It's on the smaller side. It is a male. We can tell that because it has little hooks on its fingers. The females don't have that. So let's get to measuring them. So first, we're going to be doing nose to tail in centimeters again. 8 centimeters. Mark everything down in your journal again. Next, we're going to be doing length of legs. This one's the tricky part. Okay. Make sure you straighten this out so that it's fair. 12.5 centimeters. Next, the width. We're going to be trying to go in the widest part where they get about fatter with their lungs and stuff. Now, for this toad or frog, we're looking at 5.5 centimeters. So, yep, that is about what I was expecting. Now, I'm going to put this guy back, and I'm going to get to the next specimen. Okay, this is specimen number 2 for the frogs. Just by looking at him, we're seeing that he is about the same size as the last specimen. He has a bit lighter coloration. And we see that he is indeed a female because he does not have the hooks on his hands. And the reason that a male would have the hooks on the hands is because when they do the mating process, the males need the hooks to hold on to the females. So this is a female because he does not have the hooks. So now we're going to get to measuring them. Okay, first off, tailbone to nose. So this guy's coming in at 8 3/4 centimeters long, almost 9. Next, we're going to be measuring the legs. So this is going to be 12.5 centimeters long, and last, the width. This guy is 5.5 centimeters long, so he's a bit bigger than the last frog. Now, if he doesn't jump away, I'm going to put him away. Okay, now we have specimen 3. This guy is the smallest of the frogs that we have here. He is he's definitely not as light as the last one, but he does not have much color. So, yeah, he's the smallest of all of them, so we should be seeing something like that. And we're going to be doing that now. So first, I'm going to be measuring the nose to the tail. This guy is 7.5 centimeters long that way. Next, we're going to be measuring legs. This guy has 11 centimeter legs, and then the width. This guy is going to be 4 4/4 centimeters wide. So that's it for this guy. Okay, so as you can see, with specimen number 4, we're starting to get a bit bigger, right? This guy is much bigger than the last two. We can see that he has much more yellow coloration. So we should be expecting results similar to that. So let's measure first nose to tailbone as usual. So with nose to tailbone, we are getting a complete 12 centimeters, much larger than the last one. So next we're going to measure these long legs. Make sure they're fully flattened. These legs are clocking in at 18 centimeters. And last, the width. This guy actually does not look as wide relative to his size compared to the last one. This guy is at, yep, only 6.5 centimeters wide. So, relative to his length, that is not very wide when we looked some of the other ones that we were looking at. So, say goodbye to specimen number 4. Okay, so this is our final specimen, specimen number 5. He looks to be the biggest. He has very yellow-green coloration. But one big thing to note is that one of his legs actually has a deformity. Now, I have no idea if it was born like this or if it was taken off by a predator, but there are some little toes starting to form, much closer to what we would normally see. So, I have no idea what that's going to entail for this guy. If that grows back, I don't know, but we'll see. So, I think this guy should be the biggest length and width-wise. We're just going to be measuring this long leg, just to be fair. So, length-wise, from nose to width, this guy is a full, wait, let me make sure that is good. A full 14.5 centimeters long. So that's the longest we've gotten. Now, width-wise, we're going to be measuring this guy is clocking in at 8 centimeters wide. And then we're going to do the leg last. He has one good leg that is clocking in at 19.5 centimeters long. So, in this next segment, I'm going to tell you what these different attributes means and which animal in the wild is going to be more likely to survive. Okay, now after measuring all the frogs, I think that the most likely chance of all of them surviving would be specimen number 4. So specimen number 4 was the biggest, and he had very long legs, which gives him quite the jumping capability. So frogs, they're very territorial, so that's why the width comes into play. It's not so, I didn't weigh them because it's not so much the weight, but as much as their volume, because the great chance that they ever survive is from really other frogs, right? So they'll be at the creek and they're going to be they're very territorial, and what happens is these frogs, what they want to try and do is they want to try and make them look as big as possible, so however big they are, volume wise, is what's going to determine that. So I decided that width would be the most important thing. So that's why I think that specimen number 4 is going to have the biggest chance of surviving, despite him not being the biggest. The reason that I don't think the biggest one, specimen 5, is going to have the best chance of survival is because he does have the deformity on his other leg, making him very susceptible to predators, as he does not have quite the jumping capability as the other frogs. Now, the one that I would say has the least chance of surviving is the specimen number 5, because again, he is very vulnerable to predators, and I would guess that he obtained that injury recently, because it is very unlikely that he would have grown and been able to thrive in his environment the way that he looks to have done with that injury. So I would assume that he grew to quite a large size as he is right now, and then have sustained the injury from something like other frog, or even a fish, or even a snake. So I'm not exactly sure, but that is what I think would have the best chance and the least chance of surviving. So what you guys are going to do is you're going to just write down what you think is whatever animal you've done for all of your different animals. You're going to say which one you think is going to have the best chance of survival and which one does not have the best. Okay, so now that we've done the experiment, I just wanted to give you some quick information on these snakes because they are quite fascinating animals, right? So the thing about these water snakes is that they are highly, highly defensive, and if you catch one, there's a very, very good chance that you're getting bit. Now, these snakes are non-venomous, so it's not going to send you to the hospital, but it could make you bleed. So while these snakes aren't venomous, they do have something known as an anticoagulant saliva. Now, that sounds a lot more dangerous than that is, because all that really means is that their saliva, when they bite you, it acts like a blood thinner, and that way your blood, instead of clotting and creating a scab, it's going to just keep bleeding and bleeding. Now, these guys, another interesting thing about them is that they prey on anything in their pond, and like that could be frogs. They eat things that are much bigger than them. Small fish they will eat, really anything. So these snakes are really quite fascinating. Yeah, I would recommend you doing more research because they are quite interesting species.